Welcome to the molecular device webinar on axon conventional electrophysiology. My name is Jeffrey Tang, and I'm the product manager of axon conventional electrophysiology product at Molecular Devices, and I will be your host and presenter today. So let me introduce myself. I got my PhD degree at the Department of Molecular Physiology and Biophysics of the Vanderbilt University, where I studied calcium modulation by mGuar and synaptic plasticity in striatum. After that, I did my postdoc training at UC Berkeley and UCSF, where I studied synaptic plasticity in the hippocampus and signal transduction of NMDA receptor respectively. At 2007, I joined to Molecular Devices as an application scientist. Now, before we begin, let me invite you to submit questions using the Q&A window on the right-hand side of your screen. Now, you can press on the Q&A buttons on the toolbar to expand the Q&A window. And in the Q&A window, you can type in the question and press the send button. Now, let's get started to my presentation. So I have received questions, so let me start it. So today my presentation, the title is Action Potential Analysis in Clampfit. So in the past several years, I have received questions from the customer asking about how to analyze action potential, So this, the following is the frequently asked questions. So how can I measure the frequency of action potentials? And the basis of my recording is drifting, and it is hard to analyze the spike. And how do I stop the spike? And my recording is too noisy, and it is hard to retrieve the spike from the noise. So when I do the event search, how can I avoid the large spike of stimulation artifacts? And how do I perform a phase plot of the dV over dt versus voltage in Clampfit? And also, how do I calculate the cardiac action potential duration at 90% of repolarizations? So today I'm going to address all those questions. So what we learned today is baseline adjustment and event search, and we can soften the event, and also we can also reject unwanted noise and unwanted events. And we can also align the spike, and we can also combine traces from different files, and we can also plot the phase plot. And of course, we can do the action potentials measurements. Now, regarding to these features that in the Clampfit that you will learn about manual, baseline adjustment, and we will talk a lot about the event detections of the virtual search. And I know some of you may already use that, and some may not know what is virtual search. And also we'll use the time shift to align the spike together. And also we'll use arithmetic calculation, how to plot the phase plot, and also to combine the traces. And we can also use the statistics to do the action potential analysis. Now, for event detections in Clampfit, and it is very important to have a stable baseline. And you can see from this slide is that the baseline is not stable, and you can see this portion is drifting right now. So what we want to do is that we need to adjust the baseline so that we can have a stable baseline for us to do the event detection. Now this slide just shows you how we can capture the spike event in the gap-free recording. You can see there's a trace of action potential here. Okay, now there are two important lines. One is the trigger level in here, and one is the baseline level. So once the event crossing the trigger level, okay, the event will be accepted. So you can see there's so many action potential spikes are accepted or captured in this example. Now we can also, the event in the gap-free mode, okay, can be extracted. okay, and transformed it into a sweep file. So you can see here, this action potential is basically recorded under the gapping mode, and then we can capture those action potential as a single action potential in a sweep files. Now we will show you how to do that in the later part of my presentation, okay? And the later part of my presentation, I will use a Clampfit as the live demonstration to show you how we can do that. And then for the noise and event rejections, so in Clampfit, there are several ways of rejecting unwanted events. Now, which methods to we use depends on the nature of the unwanted event. Now, for example, if the event is very large, okay, have a large amplitude relative to the action potential, that we can use the event rejection method is amplitude. So we can reject the amplitude is larger than the action potential. Now, if the event is very noisy, that we can use the noise rejections. And or the event have the certain length, or the event that needs to have a minimum event length, that we can use the event rejection based on the event length. So I will use the following slide to show you the example. Now, for unwanted events with a large amplitude, okay, for example, in this slide, I show you here, you can see a 4 beautiful action potential, but you also see a spike, a future spike with large amplitude. Now, what we can do is that we can set a rejection level. Okay, we can set a rejection level there. Now, any event above this rejection level that can be rejected. Okay, so that's one thing that the rejection is based on the amplitude. Okay, I will show you later in the Clampfit how we can do that. Now, noise usually has a shorter duration than that of the action potential. So therefore, for noisy events, what we can do is that we can set a noise duration in milliseconds to reject the event if the duration is shorter than the defined noise duration. Okay, so basically we can set up a noise duration. Now, if the noise, the duration is shorter than the one that we define, that also will be rejected. So in this case, so the noise duration can be set up so that to reject the noise spike. So this 3 spike, because the duration is very short compared to the action potential, so they get rejected. Now we can also set the minimum allowed duration to eliminate short events, and also we can set maximum allowed duration to discard events that are too long. Okay, so in this case, I use this example is that those are spikes because the duration is very short, so that we can set the minimum allowed duration. If the duration of those spikes is less than the minimum allowed duration, they will get rejected. Okay, so you can see only this action potential, okay, is accepted. Now, then we will talk about the peak alignment. So in this example, in this slide, you can see this is two traces here, and then this is basically a current injection to evoke the action potential. Now, you can see this first spike of different traces. Right now, they are not aligned together, but we can align the first peak together, okay, of these two traces, as shown in the right-hand side. Okay, I will show you how to do that. And then we can also, and I will also show you how to combine traces from different files. For example, this traces is from file A, and then this traces from file B. Now we can combine these two traces together to get this figure. And then I will also show you how to, implement this trace plot. So by plotting the dV over dt versus the voltage. I think that is very important for people studying the excitability of the neuron. Now, at the end, I will also show you how to measure for the cardiac action potentials. For example, the resting membrane potential here, and then the action potential amplitude, and what is the action potential duration for the 50% after repolarization or 90% of after repolarization. and also we can determine what's the maximum slope of the depolarization. Okay. Now let's look at the main theme of today about the event detections of the first source search. You can see in here in the right-hand side. I will spend quite some time to talk about in each features in these boxes. Now, for the category, okay, so basically each category represents a unique search criterion, and there are up to 8 different criteria, different categories. So for example, for today, you probably only use one, but you can up to 8 different categories. And then the positive and negative going describe the location of peak relative to baseline. Now, for example, action potential is a positive going event, so you should check the positive going. And then another important feature is that you need to bring the markers. 2 important markers is one is the trigger marker, and it is the baseline markers. So we can set the baseline and trigger marker by moving the slide. Okay, moving the line. 0 is the baseline marker, and the 2 is the trigger marker. We can move the line, or we can type the number here. Type the number, and here the baseline, right? And also we can type the number here. Okay. Now, if the event cross the trigger level, the event will be accepted. Okay. This all 4, in theory, will be accepted as a event. Now, we also have okay, this show you here. Now we also have another feature is called rearm. Okay. Now rearm is basically a fine-tuning in event search. So the start of an event is determined by the crossing of the trigger level. So for example in here, now here is the trigger level. Okay. Now the upper panel I don't use the rearm, and the lower panel I use the rearm. Now the start of an event is determined by the crossing of the trigger level. So in here is the start of an event. Now, if no arming level is selected, for example, in this case, the next crossing of the trigger ends the event. So when the event comes to here, that will be the end of the event. Now, if you specify a value for the rearm level, for example, here we put a delta 10 millivolt above the baseline. Okay. Now the crossing of this level will indicate the end of the event. So right now you can see the ending of the event is prolonged compared to this one with no rearm, without rearm, and this one with rearm. Okay. So in this case, that you will change the duration of the event length. Now, I've been talking about, you remember that we talked about this 3 different ways to event rejection, to reject some unwanted event. Now, this is something that you can set in the Clampfit in the first source detection, first source search. Right, in this slide, just show you an event rejection is based on the amplitude. So let's just say, I just repeat a little bit again, so that in this 3 spike, with a huge amplitude relative to the action potential. Now we can set a rejection level here. Now we know that there's a baseline level, trigger level, and we can also set a rejection level. So any event above this rejection level, in this case, this 3 spike, will be rejected. Now I also talked about the noise rejection in the previous slides. So in Clampfit, in the first source detection, that basically we have the noise rejection that I'm talking about, that you can set the number in milliseconds. As we know, the noise, normally the duration of the noise is very, very small relative to the duration of the action potential. So in this case, I set 1 millisecond. So if the noise duration is less than 1 millisecond, that will be rejected. So you can see here, if I don't check the box of noise rejection, now all those spikes will be accepted as the event. Now if I set 1 millisecond here, now all those three noises spike will be rejected. Now, now we talk about the P-trigger and post-trigger. Now, the P-trigger and post-trigger links help to extract a segment of trace before and after the event. Okay. Now, for example, in this case, in the right-hand side, I put P-trigger for 5 milliseconds and post-trigger for 20 milliseconds. What that means is that, the 5 milliseconds before the trigger will also be extracted, and also 20 milliseconds after this trigger, and also will be recorded. So that is the way that we can set the P-trigger and post-trigger. And it's basically, you can see the length of the event will be recorded longer than this one without, the P-trigger and post-trigger length. This one, we don't set anything for the P-trigger and post-trigger length. Now, this one of event rejection is the third method. To remember that the first one is about the amplitude. If the amplitude is so big that we can have a rejection level. The second way to reject the event is by noise, duration. Now, this one is the third way to reject the unwanted event. That is basically based on the minimum allowed duration and the maximum allowed duration. It depends on what you put it here. Now, in this case, in this example, I put 1 millisecond is for the minimum allowed duration. What that means is that any event with a length duration less than 1 millisecond will be rejected. So in this case, if I don't set any minimum allowed duration, now you can see all this spike and also this 3 tiny spike, will be accepted as a event. Now, if I set the minimum allowed duration, in this case, because the duration of those small spikes is the duration is worth small, so that they will all get rejected. You can see the duration of those spikes is less than 1 millisecond. So I mean, in the real case, of course, you will have different, different types of different shape or different amplitude, different duration of unwanted events. So you can play around with this number, so you can get rid of those unwanted events. Now, this slide just shows you something that we can manually consider the event, in the Clampfit and the virtual detection. Now, you can see that we have the accept, reject, and suppress, and accept plus test. So in this case, the first 2 spikes, I say you can click manually accept, so they will accept it. I will show you later with the Clampfit demonstration. And these 2 spikes is rejected. You can see there's no denoted, right? In this case, you've accepted. You can see the small diamond here, and this is rejected. And if you hit this button, this will be suppressed. The suppressant will be, you can see the gray diamond. These 2 spikes, I choose to suppress. And the last 3 spikes, I select for the accepted, and also I keep a tag there. And the event, the state of the event can be reported in the event result sheet. So you can see here that accepted and also accepted and tag will be seen in the result. Now, if you also want to see the suppressed event, now you need to go to the event detection, show suppressed event. They will also show it to you. Now let's talk about the phase plot. Now if you want to plot the phase plot, now you need to select the trace first. Example for this one is the beautiful action potential. And after this one, you need to go to the transfer trace to transfer this line as a text format. So they can see there is time, there is the amplitude or the voltage. And then in this column, then you can calculate the dV over dt in column arithmetic function, like column C equal to differentiation of the column B. So you can have this number. And then after this one, you can plot this one as the y-axis, this one is the x-axis. So you can plot this graph. Okay. Now, let me go back to the turn to the Clampfit. So I will do the some demonstration to you how we can do all the things that I just mentioned to you. Now, first of all, we want to study how to do the baseline adjustment. Okay. Now I have something here. Okay. Now I get out the file. Okay. So, and then you can click this one. You can see the whole auto scale. Now this one is, you can see the baseline is not is drifting. Now if I don't want to see these two panels, what you need to do is go to the property, and then I want to hide these two signals. Right. So now you see more clearly now. Okay. Now what I need to do is that I want to adjust this baseline. Now before that, you need to know that what is the resting memory potential? Okay. Now the resting memory potential is about minus 55 in here. Right. Now this is the depth-free mode for the action potential recording. Right. Now what I need to do is that I need to go to analysis and go to adjust for the baseline. So I want to adjust manually. Hit OK. Right. Now you can see there's a purple line here. Now what you need to do is that you just drag the line, and also you can add the point. Okay, add any point to the line, and then you can also move the point. Okay. The more point that you add, it will be more accurate. Okay, now you can add more. You can add more here. Okay. So I think it's pretty good right now. Of course, you can put more, more points. Okay, to give you more better result. So after this one, I just hit OK. Now you can see the baseline is quite flat right now. Okay. Now of course you see the shift. The baseline right now is at 0. Now what you need to do is that you can go back to adjust baseline, because you already know that the resting memory potential is minus 55. So you need to type 55 and hit OK. You can subtract the fixed value. Now you can go back to here. Now after this one, now we can do the first search. Okay, search for the event. Okay. Now let's do the second experiment right now. Okay. Now let me open another file. Okay. I want to do one more time. We did this for the auto scale y-axis. Now you're going to hide this two panel. Go to properties. All right. Now I want to do the event search. Okay. Now this is basically a long recording with 100 seconds. You can see a beautiful action potential here. Okay. Now what I want to do is that you go to the event detection, and then you go to the first search. And you can have this window. Okay, this is what I told you earlier. Now that is basically, I have said that there's a category. You can have big category, and this basically is really helpful. I will talk about that if I have time. Okay. Now you have the baseline in here, and then also you have trigger baseline. Now you can move this line. Okay. Or you can type the number here also, and also you can move this line as a trigger level. Trigger level. Let's say here, I put it here. Okay. Now you can set trigger and post trigger. Okay. And then I don't set any event rejection because I don't see any spike here. I don't set noise rejection. I don't set it here. I don't see if I set the reject here, you can see I don't need to in this case. Okay. Now, and then also you can, for the full trace, you can use the cursor. Okay, if you want to hide, you want to just analyze this portion, and you just need to select the cursor 1 and 2. Now I use full traces in this case. Then I hit OK. Right. Now they start to search. Okay. And here is basically it's very important icon. Now I talk about this one. And the good thing about the Clampfit is that if you go to here, it will tell you what is that. Okay. You can go to non-stop. Okay. Non-stop. Okay. In this case, and you see they keep searching for the event. At the meantime, you can see the event viewer. So basically, they are sorting the amplitude, sorting the action potential here. Now it's done. Okay. Now we have 810 events here. Now in this one, you see there's a tail. Probably it's because at the end, okay, the last one. So this one, you can easily to have, you can delete this one or this one. Okay. Reject it. Okay. Hit OK. You don't want that. Now you have this beautiful sorting of the event. So right now, 809 events right now is in this one. Okay, so in this file. Okay. Now you can save. You can save this one. Okay. Now I show you right now event search and also this sorting. And you can save as a file. You save this one. Okay. Of course, I will save it. Okay. So now I just cancel it right now. Okay. Now, then right now you want to open this file. Okay. This is the file event. If you want to open it. Okay. Now, so you can see this. The event sorting here. Now you can also take the average trace here. Okay. Hit OK. I want to average the trace. Hit OK. Now you can see this is a beautiful action potential. Okay. Now I want to use this example right now. Okay. Okay. To show you now. Right now I already done with the event search and event sorting. Okay. And now I want to show you how to do the phase plot. Okay. The phase plot. Now I want to use the slice. Now what you need to do is that you need to go to the transport trace. Okay. Transport trace of this action potential. Okay. What you need to do is that because you only need this one. This is the average one. Hit OK. Now you see this one is the time, and this is the trace 810. Now this one is basically is the voltage. Now you can format the column, rename it. Okay, this one you can rename it is the voltage. Okay. The next one I want to name it, this column is dV over dt. Hit OK. Okay, I showed it before, transfer traces, and now you can use this one, use arithmetic in a Clampfit to calculate the differentiation of this column in here. Now what I want to do is that you can use column arithmetic in here. Now column C equals to differentiation of column B. Now basically you can see the function here. We have a lot of different functions. You just go to here. Okay. Or basically you can also type it. Okay, you can see column C equal to, you can see the function, and you can type column B. All right. Then for the full column, then when you hit OK, You can see here. This will give you this dV over dt. Now, if I want to plot dV over dt versus v, so this will be the x-axis, and this will be the y-axis. Just click here. And I can easily go to here, create a graph. Now you can see there's a phase plot here. It's very beautiful. Okay, phase plot. All right, let's close this one. Let me also can clear all the sheet. Okay. Now, the next experiment I want to do is that how we can reject unwanted noise or event, okay, to do some unwanted event rejection. Now, let me go to bring out this one. Now, let me redo again, okay. Click here,